Hello, everybody, and welcome to our Inventors Gathering for February 2026, which is our Volunteer Appreciation Night. This is one of the most important inventor gatherings that we have. We used to call this a fundraising gala, but tonight we're not really fundraising. We're just trying to appreciate the many volunteers, some of whom are here in this meeting, not everyone could make it, who are helping make the world a better place through public invention. So tonight, I'm going to give an introduction to public invention and to Lauria Clarke, and then we're going to be presenting some awards not associated with projects. Public invention doesn't give an award to every volunteer, but we do try to recognize our volunteers because most of them are not getting paid. And so appreciation is sort of the way that the open source movement tends to reward people, and it's the way public invention does it. And then we're going to do something really fun, although it'll be a little chaotic. We're going to talk about the very large number of projects which public invention is working on at this time. We're working on over 10 projects. They're not all being presented tonight, but some people will present today. I really wanted everybody to see each other's projects. Generally, the way public invention works is we work on a team basis. And so we tend to meet weekly within a team, but the people on one team may not know what the other teams are doing. So this is a chance to see that and also to recognize people. And then we'll have time for a Q&A and some other things. So what is public invention? Well, public invention is the name of our U.S. 501c3 public charity, but more importantly, we're trying to create a movement which will be much larger than this small organization. What we're trying to do is to build an idea of inventing in the public for the public. Now, this is not a new idea. It's been done for a very long time, since at least the time that Benjamin Franklin refused to patent the Franklin stove that he created. Jonas Salk refused to patent the polio vaccine. Buckminster Fuller espoused this philosophy, and Richard Stallman created the free software movement, which embodies some of the same ideals. So the open source software movement has been extremely effective at creating a world in which software is free and open and usable and modifiable by anybody. It's empowered software engineers all over the world to use very powerful software, some of which you'll see here, and to participate in the development of that software by making modifications to it, reading the code, and generally not just being a consumer of the software, but also a producer of the software, whether they actually have written a project themselves. Sometimes that participation is simply by submitting a bug report, but that's an important part of the process. Now, we're trying to imagine a world in which a large number of people who have an interest in it will be able to participate in the process of invention, not just in software and not just electronics hardware, but all kinds of things. I personally believe technology is the most spectacular way to love your neighbors around the entire globe. Of course, we can think of firefighters and policemen and doctors as people who help people on an individual basis. My wife, for instance, is a public interest attorney. She helps people on a weekly basis. But technology is really big, right? Sanitation and the polio vaccine have saved an awful lot of lives. No one doctor has done as much as the work pioneered by Florence Nightingale, for example. And so by being participants in technology, we are moral agents, whether we like it or not. Now, some technology is kind of obviously bad, like nerve gas. Nerve gas is not a useful invention. Some technology, like the polio vaccine, is kind of obviously good. Most technology is somewhere in between, and it's a lot harder to say what the moral implication of your action is. But that doesn't relieve you of the responsibility to do it. And so even though we live in a world of uncertainty, what we're trying to do is to invent in the public interest things that improve the world and improve humanity in general. Now, why do people volunteer for public invention? A lot of the people who do so are in this meeting. Thank you for coming. Some of them want to work on open source research projects that help all humanity, as I was just saying. Some of them want to work in the light with a team of volunteers, which is the way we organize our work. And it's not a light thing to say that you get to work with a team, because it's hard to put a team of volunteers together by yourself. And so public invention gives you smart, motivated people to work with in a common interest. And that's very precious. In fact, that's one of the main reasons that people go to universities. You can also build your skills without paying tuition or doing exercises. Everything we do is real. I have nothing against exercises, but when you, especially when you're an undergraduate, normally you just do homework after homework after homework, taking tests, the answers to which are already known, right? You're not faced with any new problems. Public invention is perhaps a little humble. It doesn't quite, we're not building a hyperdrive or a rocket ship to Mars or something like that. We're doing simple things, but they're real. And they're real things that have never been done before. They're real research. And some people enjoy public invention because you get to publish academic papers, which takes a certain amount of mentorship. In my opinion, we provide excellent mentorship, not just through myself, but through people like Dr. Baskaran here, Lee Erickson, who I hope will be here, and other team leads such as Victoria, Lawrence, and Vincent, who have really grown into creating teams which are socially cohesive and technologically effective units. And then some people want to do what they love and love humanity at the same time through technological gifts. And that's what we're doing. So tonight we want to thank all of our many volunteers, even if you don't get an award. Not everybody gets an award, but we thank everybody, even if they haven't worked for public invention long enough to receive an award or for whatever reason have not. So now I'd like to introduce Lauria Clarke, who is a humanitarian, engineer, artist, and teacher. I may not be able to introduce her quite as effectively as she would like. She first came to public invention in 2020 at the height of the pandemic, and she helped make one of the most important inventions or most successful inventions that public invention has done, which is the VentMon, which is a portmanteau of monitor for ventilators. And these were simple devices that measured pressure and flow with a significant amount of software attached to them, which were used to actually measure the effectiveness of emergency pandemic ventilators. Now, by which I mean the kind of ventilators used in hospitals to keep people alive. Now, it may be somewhat forgotten. It was a long time ago, but there was a time when there was a real danger. The Western world was going to need like 1 million ventilators, which we didn't have. That turned out not to be the case for two reasons. One, social distancing worked, and secondly, the COVID disease has a strange characteristic called happy hypoxia, where you don't need to ventilate as many people as you would under other circumstances. So, Lauria, are you about ready to present?
Absolutely. Thanks for the introduction.
Okay, I'm sure you can correct me. Do you have anything to share?
Yeah, I'll go ahead and start sharing my screen. So as Rob mentioned, we met in 2019 at the height of the pandemic. I think during what was an Arduino open source hardware gathering online on Zoom. And my recollection is that during this at the end of this presentation with Arduino, Robert had an opportunity to pitch the VentMon project. Yeah, so my background is in computer engineering, and I spent a while working as a verification engineer for the logic inside computer chips. So the idea of testing things to make sure that they actually do what we expect is very near and dear to my heart. And so this is how I became involved with the VentMon project and why I found it so exciting. So this presentation is pretty casual, and I will mention that I only have a little bit of time before I have to catch a flight, so I super apologize for that. I'm going to talk a little bit about what I learned from Public Invention, my time working with VentMon, and then I'll talk a little bit about what I'm up to today. And feel free to hop in with questions at any point. So, yes, as mentioned, this is my standard title slide. I am Lauria Clarke. This is me when I was 4. Not too much has changed. I like making things. So yeah, this is our first version of VentMon, which, as you can see, is an ESP32 connected to a couple different development boards. And this was the first one that was assembled in Medford, Massachusetts on my well-loved desk. I think Robert also had another copy in Texas at the time, and we went back and forth as we built the device. And as the project matured, the look and feel of it did too. I think this was sort of a middle iteration, and perhaps sort of at the very end of my involvement with the project. I think Forrest Lee Erickson was responsible for this awesome green enclosure and the nice LCD screen you see there. I think the most exciting part of this project for me as a younger engineer was bridging this gap between physical hardware and digital data. And this was the first time I'd worked on a project where we actually streamed real-time data that wasn't just like a video stream or something like that, actually manipulable, very quantifiable data that needed quite a lot of different metrics and different display values. So this was cool. This is my first example of this type of project, bridging a hardware interface to a browser-based web interface that anyone can access. And as it turns out, this particular skill set has become totally crucial to what I do today. So in general, I'm a creative technologist. I basically do the engineering, the electrical engineering, and embedded systems development behind artworks. I recently had a chance to rebuild an artwork that I created with my undergraduate mentor when I was about 10 or 12 years ago. And it was super satisfying to see the difference between my work in 2015. So I received this sculpture sat outside for 10 years in my professor's yard. And eventually it stopped working in that time. And he contacted me about 6 months ago saying, hey, I have a solar show coming up. Can we revive this sculpture? And so I received this box of like crusty, rusty electronics in the mail. And it was really fun to open it up and like, oh my gosh, what was 20-year-old me, 19-year-old me thinking, however old I was at the time. So it was fun to compare the 2015 versions of the 2026 version. So here we have an Arduino Uno, and today I mostly use ESP32 based devices for this type of embedded systems project. And again, in this particular instance, this installation was indoors, not outdoors. So this sculpture, should have mentioned this sooner, but this sculpture has this LED animation that's controlled by an analog anemometer. And so For an indoor installation, we decided that it would be way more fun if anyone could browse a map and pick a location anywhere in the world to find out what the wind speed was and the ambient air temperature, which affects the color of the animation. So for me, this project was super satisfying as a retrospective look at the past 12 years of my growth as an engineer, and a good reminder of how do we bridge this like hardware to interface gap. There's so many different ways. Today I work for a large electronic art studio in Montreal for the artist Raphael Lozano. And we are called Antimodular Research. There are about 20 people who work there. A couple of Raphael's more well-known works are this one, Pulse Topology, which records a user's heartbeat using a sensor and photo. Oh, I'm very bad at saying this word, so excuse me. Photoplasmography. Anyway, using the changing color due to the oxygenated blood coming in and out from your pulse in your hand. We can determine your pulse using a camera, and then each user's pulse is recorded in a single light bulb. So the whole constellation becomes a record over time of participants' heartbeats. And the effect is quite dramatic. We also work a lot with breath. And this is another pretty well-known installation, which I think debuted in 2017. In which people enter a small room, and over time, the percentage of CO2 in this room increases due to everyone's breath, reaching a hypothetical point at which no one would be able to breathe. So my role at Antimodular, I'm effectively an embedded systems engineer, but for the artwork. So today I'm here at the lovely Best Western Plus Toronto Airport Hotel, working on the project shown, not actually at the hotel working on it, but here with our fabricator in Toronto, working on this large interactive public sculpture that's going to be installed on the Toronto waterfront. So it's a big arch, and the idea is that the public is able to complete this giant cantilevered stainless steel shape, and it lights up when you actually support it from one end. A lot of what I do in this type of artwork involves building custom electronics, so in this case, a custom data acquisition board that records the information from a number of load cells to determine if anyone's touching the sculpture. In effect, these electronics are really similar to what you would find in a weigh station, which I found quite interesting. So if you're ever curious about how weigh stations are protected from lightning strikes, it's a fun rabbit hole. Anyway, same way that giant metal sculptures with load cells in them are protected from lightning strikes. So lots of hardware engineering in this job, and we're constantly revising the hardware that exists inside these artworks. So in this case, I've spent a lot of time recently creating a custom ESP32 based development board that has a special audio amplifier, and this is going to be used in an artwork that contains thousands of speakers, which all make a different noise, and they're activated by viewers present in a room. So we're constantly trying to iterate on these, the hardware and software behind these artworks to make them more responsive, more flexible, and more adaptive to different installation environments. So in this case, our main objective is, how do we upload new sound files to each speaker over the air instead of having to manually pop an SD card in and out of each one, which, as you can imagine, when you get to 4,000, adds up. I'll end with this recent artwork. We recently did a large show at the Museum of Modern Art in Mexico City. And one of my jobs, or the artwork I was in charge of during this show was called Homage to Filgares. And Manuel Filgares is one of the first digital artists, pioneers of digital art in Mexico, and an inspiration to Raphael. So we knew that this kind of loose idea that this particular artwork would be these three words projected in space onto this sculpture. And depending on the viewer's location along a path, this path, which is, you can see in front of the sculpture, different words would appear depending on your perspective. That was sort of the brief, and there wasn't too much more information. This was what a render looked like. And my colleague made this drawing, but nobody really knew what was going to happen once we arrived in Mexico, and there was about a week to figure it out. So we bought some projectors with the different words. These are the kind of projectors you would see outside a store, for example, spinning on the sidewalk with an advertisement. And I arrived in Mexico with 2 Pelican cases full of stuff. I've got one right next to me right now. Don't go anywhere without them. Because we weren't sure if we were going to be using access security cameras to detect people near the sculpture. We weren't sure if we were just going to put it on a timer or project all 3 words at the same time. Lots of unknowns, and we really needed to be in the space before understanding all of these variables. So in the end, we realized that the amount of time people walk by this artwork isn't actually that long. It's only about a minute at most if you walk slowly. So we had a minute of time to capture people's attention. And therefore, tracking people all moving in the same direction wasn't going to be useful to us. So we determined that using a simple timer sequence would be the most effective way to move through the words and help people move along the path with the 3 words. So in the end, the artwork consists of a Raspberry Pi, 2 large, an audio amplifier, some speakers, a network switch, a DMX-driven switch that is controlled using ArtNet, and then the 3 projectors, each of which projects these 3 separate words from a particular location. And the final result is something like this. So you can see that from that one particular vantage point underneath the projector, you get this really clear image of the word pension. But then as you move, this fades away. And again, you reach the middle point where we begin to see the word equilibria. But as we progress along the path, this too distorts and becomes illegible, and on to the 3rd word. In all of these artworks that we make, I think in a similar way to what Rob described at the beginning, technology is used here quite heavily. And we often use different types of machine learning-based algorithms in these artworks and have been for a long time. But the focus is never on the technology. It's always on the interaction and, what type of question are you prompting viewers to ask about this interaction and about the underlying technology behind it? So how do you understand heartbeats using a camera? This algorithm itself has been around for a long time and is used in hospitals and many other contexts all the time. But to put someone in a space where they can visualize that in a different way and really feel it emotionally, it totally changes your relationship to the technology itself and gives everyone different insight. So that's the objective in all of our work. I'm gonna stop there to leave some time for questions.
Thank you, Lauria. I know you have to go soon. Do we have any questions for Lauria?
Hey, Lauria. My name is Peter. Nice to meet you.
Hey, Peter. It's nice to meet you.
How did you get started integrating your technology, getting involved in the art world like that?
I've always been curious about making things that moved, actually, kinetic sculpture and robotics, since I was pretty young. And as I moved through this journey of becoming an embedded systems engineer, I realized that the things I actually wanted to make weren't things that solved problems in the way that typical engineering often allows us to, but things that prompt people to ask questions. And this is typically the role of art in our society. And so, yeah, I'm just constantly drawn to that type of movement. Well, I hope that answers your question.
That's fascinating. What was it like? Did you have to open up your own doors, or were you invited to collaborate with a team? How did you get started?
Yeah, collaboration is always the best way to get started. I'm sure Robert can attest to this, and I encourage, this is the absolute best part of public invention. The more you collaborate, the more people you meet, and the more interesting things you learn. The coolest ideas come from the people around you, the people you meet in different contexts. And so, yeah, for me, collaboration has been the biggest factor in driving how I see both my own work in my personal practice, but then to the people I engage with professionally in the types of projects I work on today.
Okay, awesome. Thank you.
This is the latest version of the VentMon, which was miniaturized by Ben Coombs. It's all an integrated unit, a little more elegant than the one we started out with. But the one we started out with was used by 6 teams to do real research. We made 20, and 14 of them sat on the shelf, which happens. But the other 6 were actively used. So do we have any further questions for Lauria? Okay, well, I'll let you go, Lauria. I know you have a flight to catch, but thank you very much. I'd like to tell everyone, if you just volunteer for Public Invention, you can be just like Lauria.
Thanks so much for having me, Robin. I'll keep listening in. I'm so sorry for the tricky timing today. I'll have to turn my video off, but I look forward to hearing more about what all of the rest of you are up to, and it was nice to see all your faces this evening.
Okay, thank you. Okay, so now I'd like to go on to presenting the awards. We're going to talk. We've associated some of the awards with project teams, but I wanted to give some that are not going to be discussed by project teams today. And I'm going to hold up Miriam's because it's the only one I have. She was out of the country, so I did not send it to her. Most of the people have already been shipped their award. If you're outside of the country, and we have lots and lots of international volunteers, it'll probably be a while before you get it. If you're in the United States and you've been given an award and you have not received it, please let me know. It may be lost in the mail or something. But I think these are quite attractive. I don't know if Melanie is here today, but we just completed a paper for Hardware X on the Moonrat incubator. I'm not presenting that today, but she wins Best Technical Paper Contribution. And if I call your name and you're here, please come off mic and say hello. Mimi, do you want to say something briefly?
Gracias. Thank you for allowing me to be part of Public Invention for 3 years. And I'm proud of everything that everyone has been doing, is been learning, is willing to collaborate, and most important, willing to share and have the time dedicated for Public Invention. So thank you very much.
Thank you. Mimi has done a great job learning how to use LinkedIn for recruiting in 2025. And so this organization has really grown thanks to her a lot. Next, I don't think Christina is here, but Christina is our bookkeeper, and she helps keep everything auditable and ready for the IRS and do all those other things. It's a very important function, not particularly easy to do because we're kind of scattered and we have to deal with international issues and tax issues and so forth. Next, I'd like to give best paid staff honorable mention to Megan. Megan was sort of a student here in this room. I guess it was coming up on 9 years ago, and has become a paid assistant. Most of the people here tonight are not paid. I am not paid, for example. Christina is not paid, but we do pay some people. Marin O'Grady is a technical writer who's kind of taking over for Mimi, and I've come to rely upon her for all of the written word that I send out. Marin, are you here? Do you want to say hi?
Oh yeah, I'm here. Thanks so much, Rob. It's been a really great working with Public Invention for the past 2 years, so thank you.
You're welcome. Okay, so now I'm going to talk about some projects, and there are no awards associated with this, but this one is kind of special. So for the last 3 or 4 years, we've been working with NASA, who has contracted us to do some research for a digital control system of a solid state oxygen generator, which is really gee whiz high-tech space stuff. NASA wants to use it for 2 reasons: to fill spacesuits and to eventually make an infirmary in space. So far, we've never needed an infirmary in space, but someday we will. And then secondly, the same technology can be used to store oxidants, that is oxygen, as an oxidizing agent on the surface of Mars for a return trip. And so if you're on the surface of Mars and you have a year and lots of solar power, you can create methane, but you can't burn methane by itself. You have to have oxygen. And this is a mechanism for producing an oxidant. When you put an oxidant and a fuel together, you can get home. So we work with a very important charity called Kids Operating Room, which is a Scottish charity, but they make surgical theaters for pediatric surgery all over the world. They've installed more than 100, many of them in the global South, Africa, Latin America, and some in Asia. This is the lobby in Dundee, Scotland, with our equipment. We did not make the chemistry. We did not make the solid oxide actual oxygen generator, which is the most interesting high-tech part. But we made all the other electronic stuff around it that controls it and keeps it at the right temperature, which is no joke because it operates at 750 degrees C. Now, I'm happy to say that recently we've made a pretty major breakthrough that NASA is excited about on this project as well. So now I'd like to hand the mic over to Victoria.
Thank you, Rob. I realized that my red light and my nebula picture makes me look very red, but there's nothing I can do about that right now. I'm here to talk about Global Distributed Tracking, which is a software platform built under the Global Open Source Quality Assurance System, which is a project of Public Invention. And we have a launch video that we'd like to share with you. Rob, go ahead with that.
Across the globe, delivering life-saving aid. But tracking those vital shipments to the last mile can often prove impossible. Fraud and theft can be widespread with no transparent documentation to light the way. From the open source team that built a new PPE supply chain in 2020 and became NASA contractors in 2022 comes a solution. Our Global Distributed Tracking System, GDT, allows you to track aid deliveries from point of origin to the final recipient. No download, no login, no fee. With a simple scan of a QR code, you can ensure that aid reaches the right person. Because GDT is fully encrypted, documentation is secure and private, even in conflict zones. Now, anyone with a smartphone can verify chain of custody within their humanitarian mission. Global Distributed Tracking. Trust through transparency.
Thank you, Rob. So as you can see, Global Distributed Tracking is a software interface that is fully encrypted, open source, and allows you to transparently document the movement of an object through time and space. This product operates on the premise that if you are holding an object in your hand, you have the right to know where it came from. And the more information that is added to a GDT record that follows an object, the more information you have, the better it is. Because we believe that documentation is the nemesis of bad actors. If you are going to write something down, you probably are okay with people knowing what you're wanting to do. So our value propositions for global distributed tracking all center around quality assurance, preventing fraud, verifying delivery for an object. This is especially useful when you're talking about humanitarian aid, which often is stolen or ends up on the black market. End-to-end communication. How are you communicating as someone who is originating an object out into the world with your end user? How can you develop metrics that allow you to track your quality assurance protocols? And this all goes together with supply chain accountability, which is something sorely needed in the world, whether you're doing a humanitarian mission or a commercial mission. So being fully encrypted and open source, GDT has been designed to work in conflict zones. That's where the encryption comes in very handy. And it isn't an app. You don't have to download anything. So it works very well on low resolution smartphones, which a lot of the world operates by. So far, we've had some amazing partnerships that are using GDT for production line quality control. This includes Doctors Without Borders operating in Africa across a nodal additive manufacturing network, and our partners in Arizona with distributed medical device manufacturing, who are actually building upon the GDT API to create a whole distributed manufacturing ecosystem that allows end-to-end quality control to be visualized using GDT. The creation of the GDT API is going to be very impactful to creating platform integration and allow other teams to build upon our framework. And outside of the actual impacts of GDT, the product, I have to say that the team that we have working on this product is one of the best I've ever worked with. We have very engaged volunteers, some of whom have been converted to contractors. We have people that show up to our meetings who have great ideas, who are very passionate about this humanitarian focused mission. And this past year, we saw the arrival of Vincent Steffens, who we'll hear from soon, I assume, who is our lead engineer for the project. And his leadership and team organization has not only drawn more people to our team, but has helped us achieve amazing progress that we otherwise would not have been able to achieve. So we're very excited about this product, and thank you to everyone who worked so hard on it.
Okay, thank you very much, Victoria. So we call this a product because it's a finished product. It is in fact free of charge. So it is both free as in free beer and free as in free speech, in the sense that anyone can take the software and run their own version as long as they don't use our logos or our names, which would be confusing for that software. So it is free Libre software, which is open, but it is also free of charge, which is important for that application. So as Victoria mentioned, I'd like to now briefly introduce Vincent Steffens, who is receiving the second highest award given by Public Invention. The growth of Public Invention depends upon Public Invention coaches, which is the name we give to project leaders or project managers or senior architects. It depends, but we think of it really as being a coach, kind of in the sense of leading an athletic team to do it. And Vincent fits that really well. He understands all the people on his team. He uses them the way, say, a good basketball coach uses his people as effectively as possible. So the most important award given out by Public Invention goes to the best public inventor, because the coaches are not more important than the inventors themselves. But our ability to expand and form new teams does depend on finding invention coaches. And so it's an extremely important award. Vincent, would you like to say something?
Sure. Yeah. So, hey, everybody. My name is Vincent Steffens. I joined GDT about 8 or 9 months ago. And after jumping into the project and getting to know a lot of the folks who are on the team, I have to say it's an incredible privilege to work with all of the differently talented folks that we have. And I learn a lot from everybody. I've got a lot of experience I've got about 7-8 years of experience doing software engineering, mostly in the finance world and in distributed computing, and I've got some astro research experience. And so what I'm able to do is bring that and not necessarily, build things, but guide people in ways that in such a way that they are able to grow their skills in ways that are both useful towards their own goals and towards our goals. And I think that mutualism is really what helps us, what's made the team as effective as we have been over the last few quarters.
Okay, thank you. Nina, if you're here, maybe you could come off mic. Nina is really the only professional user interface designer that we have, and it shows because the GDT product looks really good, unlike the things that I designed, which look like they were designed in somebody's basement. Nina, are you here?
I am. Hi, everyone. It's always so fun to work on any of these projects. I don't know. I feel like a value instilled in me from my parents was that I should do something to help make my corner of the world better. And I'm so thankful I have an organization that lets me do that. I'll keep it short. Thanks, guys. Thank you.
Thank you. It's much appreciated. So now I'd just like to mention Victoria, who we just heard from, has really grown into being an invention coach. So I'm giving her second place award this year. She acts in the agile role as product owner for the global distributed tracking project. So she's a major motor of the project in what's called in software engineering terms the customer facing side. Victoria, would you like to just say a few words?
Thank you.
Okay, thank you. And Francesca, if you're here, interrupt me. I haven't seen you in the chat, so I don't think Francesca's here. So this is still the GDT team. The GDT team has 10 to 12 people who meet every Monday night. I'd like to give an important award, which shows how serious we are. The best security contribution to Hugh No, who has really grown into that position. He's an interesting guy. I can't tell you about all the stuff he's done in the past, but this pure software project, GDT, needs security. And Hugh has been providing that. Hugh, are you here?
Yes, I'm here. Thank you so much for the award. Thank you so much for having me on the team. I've learned a lot in the time that I've been here, and it's been a great pleasure and great honor to work with everybody on the team. It's beautiful. Thank you.
Thank you. So next, I'd like to give 3 people an honorable mention award for Best Public Inventor. Jara Rodriguez, who I sort of shoehorned him into system administration, which I hate, but he's done both that and some very important programming. Allison Gilpatrick, a young woman who recently graduated from the University of Vermont and has really become sort of a senior engineer despite her youth. And Daniil Giuseppe, if those 3 people are here, could you please come off mute and say something quickly?
Hi, I'm here. Thank you. It's been really fun working on this project.
Thank you, Allison. Jara, are you here?
Yes, I'm here. Thanks, Rob, for everything, and I hope to keep contributing to GOSQAS for a while here.
Thank you. Thank you. Daniil, did you make it tonight?
Yeah, I'm here.
Hi.
Thank you. Thank you, Rob. Thank you, everyone. I'm having fun working on this team. So thank you so much.
Okay, thank you. Now, moving along, this is a completely different project. The global distributed tracking is pure software, which uses cryptography and networking and stuff. But this is a hardware project. Gianluca, are you here and ready to take over?
Yes. So I'm going to give you a brief overview of the EcoPot project. So the goal of the EcoPot project is to design a more efficient pot to support communities around the world who use open fires to cook and heat water. This project uses a lot of heat transfer and fluid dynamics through our designs of the pots. And the goal of our research really is to save time and energy for the 1 billion people around the world who use wood fires for cooking. And as a positive consequence to this, we hope to also decrease deforestation and smoke pollution in these areas. So to design our pots, we use an open source 3D modeling software called OpenSCAD. And this image to the left is in OpenSCAD, and it's currently our best pot design so far. It uses a round bottom pot with heat transfer fins and our conical lid, which we also designed in OpenSCAD. In the bottom right, that is a graphical representation of a pot that we're currently trying to design. It has like wavy sides, so that's another cool thing. And then in the top right, we have our current physical testing method that uses a heat gun on the bottom, and then we have this attachment that holds the pot, and it has 3 metal flaps on it, which we made to simulate what cooking over a 3-stone fire would be like. And before we 3D print our pots in metal, because it's very expensive, we test them in an open source computational fluid dynamic software, simulation software called OpenFoam. And in the top left is the pot from the last slide with the heat transfer fins right before a simulation. In the bottom left, that shows during a simulation, it takes a slice of the pot, and you can see the airflow at the bottom going around it. And then the 2 pictures on the right is just the water that's inside the pot during a simulation. So the top right is the water at the beginning of the simulation, and then the bottom right is the water, I would say probably about like 2/3 of the way through the simulation, and you can just see the difference in temperature. And this is will be used to calculate the efficiency of the pots. And that's just a quick overview of what the EcoPot project is. Thank you.
Thank you very much, Gianluca. So Gianluca is awarded Best Public Inventor Honorable Mention, and Best Invention Coach Honorable Mention goes to Cledden Obengpoku. I'm very proud of this team because up until recently, it was a 5-continent team. Cledden is from Ghana, although he's currently in Denmark. Gianluca is American. Yvonne is from Argentina. Marie is from France. And recently we have Janvi Palachi from Dubai, from India and Dubai. So we almost covered the whole world. Sadly, I recently wrote a letter of recommendation to Yvonne for nuclear engineering school in Argentina, and he got in. So he has left our team. I knew that was a mistake when I did it, but that's part of my job. So I am awarding him Best New Public Inventor of 2025, although he's going to have to get on the stick if he wants it for 2026. Okay, so I don't know if Hardhik or Lawrence is presenting this, or Peter. Who is presenting for the Biochar toilet?
That would be me.
Thank you, Hardhik. Go ahead.
Hey everyone, this is Hardhik. I'm a graduate student from CSU, and we are working on Biochar toilet. Coming to the problem and the goal designs. So initially, we have observed that there are like few places in the world that which still uses open drainage system, which is like not unsanitary and also environment hazard too, because of the open fecal matter of human or any animal waste lying around on the road or sideways would attract harmful pathogens, which is also affecting the human health who are living surrounded, and also will affect the water system over there and others. So for that, we wanted to develop a low cost and electrically powered toilet system in which the fecal matter which we excrete would be turning into biochar and can be used further as fertilizers for and also can also be used as a biocoal too. So coming to how we designed it is we want to design it in a controlled chamber where both temperature and pressure is controlled, because biocharing happens at a low oxygen environment with higher pressure in it. Yes. So for this, we want to create, as I mentioned, oxygen-free environment in which we can control both the pressure and the temperature. And we need to increase the temperatures a bit slowly, slowly in order to have the organic material to be charred properly both the sides. So for that, what we designed is we have taken a pressure cooker and we have sealed up with a few pressure gaugers and also pressure valves for it to control the to control the pressure in the chamber. And also we have a few thermocouple sensors which are attached to the chamber to control the heat. And we have also controlled the hot plate using a solid state relay, which can turn on and off based on the heat of the chamber. Yes. So our first goal questions are can we detect the dryness and can we have the pressure in the chamber safe? Because handling with high pressure environment is always a hazard. And can we automate the heating process and can we turn off the heating when the pressure is detected? Yeah. So as I mentioned, this is the whole temperature setup we use, where you can see we have a pressure cooker with a pressure manual gauge reading, which we also have a pressure sensor attached at the end of the wall, which can read and translate the temperature to the ESP32 board module, which can then read the pressures in the environment and at the same time can also help us in achieving our goal. So what it does actually is it dries the material in the seal chamber, and when it detects there is no moisture content in the chamber, it assumes, and then the heating is still increasing and there is no change in the pressure, it detects the temperature, detects the sample as dried. So this is the first test we initially did. We did a number of tests actually. The first test would be using a loaf of bread, and these are the results we got. And there's one thing which we observed is due to the samples as being very small, we were not able to detect the dryness of the sample. And also there's a lot of soot residual which has been formed at the top of the lid. So these are two next goals which we are going to tackle. So this, yeah, and heading over to Peter.
Hey guys. So yeah, what we're going to work on next is we're developing an induction system with a bentonite, clay, and magnetite blend. Our hopes is to use the bentonite clay to wake up the moisture, and the magnetite embedded in that will heat up using induction coils. So we have a more thorough heating of the sample and better control, and ideally make it more efficient. We're currently modifying a Hawkins Classic pressure cooker, and we intend to bend our own coils and make some of our own modifications to the fittings as needed. But yeah, we're hoping that this will be really successful, of course.
Okay. Thank you, everybody. Okay, so I would like to give awards this year to Lawrence Kinchelow for Best Public Inventor, honorable mention for both the NASA-MCOG and Biochar, and Hardhik Pyla, who's really done a good job with the embedded engineering and the electrical engineering of that system. Peter only joined the team in October, November, so he's fairly new there. Avinash, I believe this is your slide.
Yes. All right, y'all. Thank you very much for having us So I'm representing the Librecorder project. So Librecorder is an attempt to address some of the issues around smartphone-based microscopy, mobile microscopy, or generally point-of-care or POC microscopy. So currently there are a diverse range of designs being explored for point-of-care microscopy, that is microscopy done at the interface where a patient first interacts with a healthcare professional. And so the benefits of such a system are obvious. It could be portable, easy to use, provide immediate results in diagnostics. The data could be shared and portable, and really a variety of uses come from that. So, for example, it can be used in the healthcare setting, but perhaps it can also be used to identify E. coli presence in local water supplies and so forth. And so what we realized when we've started to analyze the space of the design space of point-of-care microscopy is that each design and device is highly localized to a particular disease context and a geographical context, among other constraints. And we started asking ourselves, there are a lot of strengths and weaknesses to the diverse designs, but how do we quantify whether a design is appropriate or well suited to the disease and context it's trying to tackle? And from there, how do we design a microscope that is both generalizable and highly useful? So the first thing we did in tackling that is we took actually a couple of months to identify the diseases that most commonly affect the 50 lowest and middle income countries and segment the clinical workflow of those diseases. So for example, we see malaria at the top, and along with a host of diseases, the first biological sample that is relevant in diagnostics, blood, or abbreviated there as BLD. And from there, the most effective sample preparation technique is smear or SMR, and so on and so forth until you hit bright field microscopy at the end of the tunnel there. And so this is just an overview, but we actually have written a pretty comprehensive systematic literature review of microscope diagnosable diseases and the clinical workflows that to a very detailed level that are involved in diagnosing those diseases. So now that we have such a diagram, we now know that point-of-care microscopes need to be optimized for specific clinical workflows. So some of the elements of those workflows include site identification, sample extraction preparation, field of view optimization, sample incubation, diagnostic intelligence, and collaboration. So one example is the very famous now open flexure microscope, which is a 3D printed microscope that has a lot of these capabilities, including things like diagnostic intelligence, collaboration, and network support. But for example, it doesn't have things like sample incubation or the ability to move samples. So we're working on understanding what is the impact of that capability and how many more diseases can be more effectively diagnosed and monitored with the addition of such capabilities. So a second big part of what we're working on in Librecorder is developing a digital apparatus, digital infrastructure to support the use of these wide range of microscopes. We know that such diverse microscopes can be useful in their local context, but they can also be useful in neighboring contexts and maybe even in contexts where a whole different device is being used. So here's an example of what we're talking about. In the health channel of Librecorder, we have a set of data sets and models. These were developed by our volunteers. And so, for example, the dog cells urinary, so cell images of cells from the urinary tract of a dog. I collected these using my open flexure microscope and uploaded them to the site. One of our volunteers developed a dark light sigmoidal classifier, so that gives some characteristics of the relative brightness features on the cell on the sample. So one person's able to supply a data set, someone else is able to supply a model, and these work together to develop an ecosystem. So we're developing an infrastructure that allows cohesive intersectional data to be aggregated, and an ever-improving model library, which can be cross-trained across data sets and whose results can then be used by researchers, clinicians, and engineers developing point-of-care microscopes. So along with this, we're working on compiling data related to ecology and veterinary medicine as well. So we're working with local farmers and veterinarians in the context where I live to propagate the use of point-of-care microscopy, especially the open flexion microscope. So the hope is farmers are able to use this to analyze water supplies in their wells, to analyze semen samples from bulls, to make informed and appropriate decisions to support their enterprise. Here in Alabama, I live in a rural community in Alabama. We are working on distributing, like I said, microscopes for use in farms. And one of the things we're looking at is, are there secondary biological samples that are not usually, or that are underlooked or underemphasized from chickens, which could be used to diagnose bird flu? Well, it would be tough to have veterinarians go to every farm and collect all the fecal samples or the drainage and fluid in the eyes from every chicken. But it would be more manageable if farmers could be equipped as citizen scientists to continuously monitor their animals, which they're already doing, but empowered with open source microscopes, which are able to be 3D printed or manufactured quickly, and to help build this ecosystem of biological data. Along with that is the Tallapoosa River that's shown right there. And so what I'm doing personally in part of that is actually traveling the Tallapoosa River and mapping the ecological watershed. And lastly, I'm also working with middle school students there at the bottom who, I don't know if you could zoom in, you might see there's a couple of open flexion microscopes in the back of the room there, but they're actually getting to assist me. So they're able to collect samples from their high schools. So there's 4 rural middle high schools in the county I live in, and the students are creating a map, ecological map of the county by collecting biological samples from those as well. So that's all I've got.
Thank you very much. So as we said before, the invention coach position is extremely important. So I'd like to thank Avinash Baskaran with the Best Invention Coach Honorable Mention Award 2025 for Librecorder. Roy Phillips is here, and he gets an honorable mention for Best Technical Paper Contribution for the Librecorder Lit Review and Microscopy. I think Roy read about 250 papers. I read about 4. Roy, are you here? Can you say hello?
Yes. Hi, everyone. It's a great honor to be here. This is my first year here with Public Invention. It's been really fun kind of getting this Librecorder project up off the ground. We started from just an idea that Rob had, and our team has done a lot of reading, done a lot of writing, and done some work putting together the software and the platform to make this reality in 2026.
Thank you. Nipol, are you here? Would you like to say hello? Nipol gets a Public Inventor Honorable Mention Award for Librecorder programming. He programmed, along with Avinash, some of the software that you just saw. Okay, Nipol, you can come back if you're here. So now I'd like to, I didn't introduce Asmi, I'm sorry, Avinash very well. So Avinash recently got married, and he also recently finished his PhD, and he is a postdoc contractor for Public Invention. It is the first such one that we've ever had, and so he's one of our more senior researchers. Asmi, are you here?
Yes, I am here. Hello.
Okay, let me introduce Asmi. I've been working for 1.5 years with Asmi, and she, together we've learned a lot. As sometimes happens, I set off with ambitions that were a little greater than we could really achieve, but we're finally starting to have some successes she'll tell you about. One of the things I love about Asmi, she's a mechanical engineer at Cooper Union, which is, it's a university that's not as famous now as it was, but at the turn of the century in New York City, Cooper Union was extremely famous because it was kind of an adult continuing education university, and many famous lectures were first delivered there. And it was also tuition free. It is no longer tuition free, unfortunately, but it was a more hopeful world we lived in at that time. So take it away, Asmi.
Yes, so my name is Asmi, as Rob mentioned, and I'll be presenting the Ferrofluid pump, which, as you can see here, is an electromagnetically powered pump. And the idea was to have something with no rigid parts made from ferrofluid, which, if you don't know, is a magnetic fluid. And I'm working with Asim, who's actually in the call right now, and Sid, who can make it, and with a lot of help from Robert. Now, like we said, initially it was a little bit slower. So initially we just started with a ferrofluid plug, and we tried to understand how much pressure could it hold and how could we change like the amount of turns, the core material and the core shape, and how many things we can change to really get a strong pump or a strong plug. And we learned that the horseshoe configuration was a bit stronger, using thicker wire and a soft iron ring as a core. Kind of like those kind of initial conclusions were made to now lay the foundation of what we're working on right now. And now with that kind of foundational knowledge, we're designing a pump that works by pulling ferrofluid up by turning on and off this magnet that you'll see.
This is Robert L. Reed on December 17th, testing out for the first time the boat pump concept using ferrofluid and a 2-amp power supply.
And as you can see, it can be a little bit hard to see because ferrofluid is so dark and almost impossible to look at, really. But it is
pretty well.
It is pumping quite, like like you said, it's pumping quite well. And now after automating that pumping, we got a little bit of a more obvious and more efficient
pump with no moving parts test with 30 millisecond pull and 40 millisecond let.
And now, as our future steps, we kind of saw this initial success, and we want to start making a setup with multiple magnets, as you can see here on the right side. And these will be coiled. They're not coiled yet, but they will be coiled. And with more magnets, we'll get a stronger pump, hopefully. And that includes making a transistor setup, as you can see on the left, which is just a short video of like proving that it works. I don't know if you can press the left video or.
This is the current 4-transistor design without code. So it's just the buttons are directly driving the 4 transistors. As you can see, they do all work, and it takes amperage from the power source rather than the Arduino. Arduino serves as a voltage supply to drive the transistor gates.
Oh yeah, so like we're basically working on how to make this singular magnet pump boat into something that requires more or can use more magnets to pump at a stronger rate and a stronger pressure, hold a stronger pressure. And we're going to also consider, using air pressure. So now it's not something that has to be vertical. It's kind of a lot of future things to do, and it is really exciting. And that's about it. And thank you, Rob, and thank you, Public Invention.
Thank you. So we actually don't have any awards to give this team. A lot of this success actually came in 2026. But I do want to add one thing. I shouldn't jump in here, but I want to emphasize something because it just can't be said enough. What you just saw was not a very good pump, right? It only pumped a little bit of fluid. It has no moving parts. No moving parts. Get that? We're pumping fluid with no moving parts. This is approximately the first time this has ever been done. This is really, in my opinion, kind of a big deal. This is a game changer, because if you can make a pump that has no moving parts, you can make an extremely small version of it. For example, to move a fluid over, for example, a very hot microchip, or for other biological purposes. So it looks like a janky little toy, but this is actually a very interesting invention, in my opinion. Now, I'd like to introduce Mohamad and Mzafar, who's also in Canada. I'm very proud of our international relations, and I hope our Canadian friends can forgive some of the horrible things that Americans have said about them recently. Mohamad is going to introduce the alarm dialogue management system, which leads into the Krake. Are you here, Mohamad?
Yes. Hi, everyone. I'll be presenting the alarm dialogue management, or ADAM. So this project is alarm dialogue management is just basically an MQTT router. This project is completely software, so there's no like hardware part in it. Its goal is to manage multiple alarms and send them to multiple Krakes or annunciators or whatever thing. So this alarm management, it will have multiple functions, such as recording all interactions for post-hoc interactions, present the highest priority problem to the human responder, manage the escalation of alarm levels without allowing any needed action to be forgotten, and managing new incoming alarms conditions so they are correctly presented to the responder, and to allow alarm muting so that if there's perhaps a higher severity alarm, the operator can mute whichever annunciator they're working with so that they can focus on the higher priority alarm first, and then they can go back and check if any other alarms got in while the operator was working. This next slide it basically explains how ADAM will be working in a real life scenario. So the purpose of basically this project, people can use it in multiple industries, like let's say in a hospital or a chemical plant or a restaurant or any other things that require perhaps an alarm system. So the way it starts is that there would be perhaps sensors in whatever environment you're in, and these sensors would monitor things like temperature or, I don't know, detect smoke or something else. And once they detect something or something concerning happens, they basically send an alarm to one of the annunciators. The alarm dialogue management here comes in and gets this alarm to a server, which for now we're using a public server. But if any private companies get this program from us, they would use their own private broker. So the alarm comes into the server and it gets stored, and it sends it to one of the annunciators. And this annunciator would have the description of an alarm and the alarm level. And the description of the alarm, we programmed it to be 80 characters long. And on the screen, there will be the operator will be presented with multiple options that we have programmed, which are acknowledge, dismiss, shelve, and completed. The operator will have the opportunity to basically select one of these options, and once they select the option, they send it back to the server. And the server will then either keep the alarm stored or either delete it if the operator chooses to dismiss the alarm. And all the alarms will be logged for perhaps a harm check, or if the operator wants to check status of alarms later. And they will be logged by time, date, level of severity, and the description of the alarm. So that's it for the project so far. Thank you for listening.
Thank you very much, Mohamad. Mohamad is fairly new to the project. So I would like to give Saitran Vishwanatha an important award for the best computer simulation of 2025. We didn't show it today, but he wrote a complete simulation of a lot of those features, including simulating the response time of human being in response to alarm fatigue. So it's really, he's really done an excellent job of that. And Saitran writes very, very clean and crisp Python code, which I do not. Saitran, are you here? Would you like to say a few words?
Hello everyone. Hi.
All right. Well, we really appreciate Saitran's work. So I did want to mention one thing that Mohamad did not emphasize, which is there are, of course, alarm management systems all over the place. There's a book, this one by Hollyfield and Habibi, that talks about that subject. But as far as I know, there are no systematic open source alarm management systems, and certainly nothing like what we're building. And so I think we're breaking new ground with that project. And I think it's actually going to be very significant. Now, he talked about an annunciator and the fact that that was a software project. Now we're going to present the hardware component, which is the annunciator for that project. This is another team that I'm very proud of because it's very international. It's run by Naram Kir, who has grown into becoming a great leader for this team. She's in Lebanon. You're going to hear the voice of an English woman in Scotland, Courtney Ludick, on the video that they're going to have me play. It's also, there's an excellent mechanical engineer, Yahya Ayman, from Egypt, and recently a woman from India, Yapti, has joined as well. And this team is mentored by Lee Erickson. I don't know if he's here, but Lee is a really excellent mentor for those kinds of things. So I think they have a video for us to play.
The Krake is a dedicated wireless alarm device designed to inform human operators of critical conditions they need to know about, clearly, reliably, and without distraction. Krake is an annunciator, a hardware device designed to get a human's attention and inform them about a specific problem. Krake have a protocol to handle alarms and process the response of the operator. There are a variety of uses for the Krake, such as in assisted living scenarios or in pairing with other equipment, medical or industrial, or to any other machines in your residence, providing immediate alerts for events based on policies and severities that are implemented by the ADAM and by a separate ADAM project. To maximize interoperability, the Krake is designed with both API and UART connector, RJ12 and RS232, allowing Krake to be connected to equipment without Wi-Fi capabilities, acting as a peripheral device announcing the alarms of the machine it is connected to. The alarms are divided into 5 levels of severity, ranging from informational alarms to critical and emergent alarms. Krake helps deliver alarms that are timely, meaningful, and trusted when they matter most. Krake features 5 bright LEDs for visual alerts, a customizable audio system for speech and alarms, an LCD display along with a rotary encoder for simple menu navigation, and a mute button to handle the alarms, Wi-Fi network connectivity, and 2 different power options to enhance its versatility.
Okay, so that was the voice of Courtney Ludick, and the part of the reason they submitted a video is because it's in the middle of the night for Courtney and Naram. Courtney's in Scotland, Naram's in Lebanon. But nonetheless, Naram may have gotten up. Naram, are you here?
Hello. Yes.
Hi.
Oh, thank you, Dr. Reed.
So
I hope you liked the video.
I did. So Naram has really grown into this position. She works, I don't know how many hours a week, unpaid for Public Invention. So it's my honor to present her the Best Public Inventor Award of 2025, which is the highest award presented by Public Invention. So yay for Naram. Naram, please say a few words.
Thank you. So Krake's team doubled in size during the past year, and unfortunately, due to the late hour, most of Krake team is not present today, as Dr. Reed just mentioned. It's 4 a.m. and 2 a.m. for my teammates. But we hope you liked the video we collaborated on. So Krake, as mentioned, it's a peripheral wireless alarm annunciator designed to transmit critical alerts to human operators. And recently, Adam started growing as well, and we hope together we'll be bringing a useful project to the world.
Thank you. Thank you. Lee, are you here? If you're here, come off mute and say hello. I assume Courtney's not here. Courtney, if you're here, come off mute. So even if he's not here, Lee, I think maybe for the third time, receives the Best Mentorship Award for 2025 for mentoring both Moonrat and Krake. And Courtney Ludick and Gianluca Knutsa both received Best Public Inventor Honorable Mention for Krake enclosure design, which you just saw. That white 3D printed enclosure design was designed by Courtney. Naram, by the way, does electrical design, layout design, software, and a little bit of CAD, and she manages the team. She does a great deal. And then we've come to rely upon Gianluca Knutsa to take over some of the software responsibility from me. And he's a very good C++ embedded engineer. If Courtney's not here, Gianluca, I think you are. Would you like to say hello?
Yeah. Hello. I'm Gianluca. Thank you very much for this, Robert. And yeah, no, I'm happy. I'm enjoying my time helping at the team and doing some actual embedded development.
I forgot to mention that one of the first things that Gianluca did was move us from the Arduino IDE to the Platform IO system, which is a much more professional embedded development environment. And that was a useful thing to do. Okay, we're getting near the end here. So I really appreciate everybody who's stayed. So thank you. I would appreciate if people donate, subscribe, and contact. We have a good YouTube channel that is getting better all the time. You know, small donations of $20 from small, you know, we're never going to raise our operating budget that way. But if we get 100 people to donate $20, we prove to the US IRS that we are a public charity and that we deserve to continue to have our charity status. So we do request small donations from people, which can be made at our website. I also think people should subscribe to our YouTube channel because we produce not necessarily the most polished stuff, but very rich and interesting YouTube content. And then the blog on our website is fairly active and fairly interesting, in my opinion, as well. But Public Invention as an organization is not really that important. What's important is that the world be full of awesome public inventors, people who invent in the public for the public, people who work in the light by showing their work on an ongoing basis so that they're inviting other people to learn from their work and sometimes participate in it. People that build things that help all humanity and that set out from the beginning of their project to try to help all humanity. And finally, Llewellyn Graham is here. He's been helping me organize an in real life conference, which will be coming soon in June in Austin, Texas. We have not fixed the date because we have not leased a venue, but we are actively researching that. And so that is all I have. And I'd like to open it up for questions. And the best questions would not be directed to me, but to one of our speakers here. If someone has a question for Victoria or Avinash or Anyone else?
Hey folks, do you mind if I have to drop soon, so I just wanted to thank everybody for all of their work and congratulate everyone. It's been wonderful to see the presentations. I'm Stephanie. I'm one of the members of the board, and thank you all for your contributions. And of course, thank you, Rob, for continuing to be the beating heart of this organization, for being the inspiration.
Thank you.
Thanks, guys. Congratulations.
Thank you. John Gibbons, who's on the board, is also here today.
Yeah, I've got a question for the EcoPot team. I've been kind of browsing your project since I joined Public Invention. I'm pretty interested in it. I was wondering, have you guys considered the use of a shroud to go around the pot?
Okay. Does anyone have any questions for anyone? Questions about the Ferrofluid pump? So I can answer that question, but yeah, so I don't think Gianluca knows that. So I have heard of shrouds, and those, like ovens, are interesting ideas, but we believe that there's value in designing a better pot, whether a shroud is used on it or not. And so what we're trying to do is to make the most sophisticated analysis of the simplest thing that we can, just a pot where you don't have any other part. Now, the truth is, if we're going to be good public inventors, we always have to think about what's going to benefit people as well as the technology. Okay. The truth is, the greatest benefit for people who cook over wood fires would be to give them all stoves, right? Just give them iron cooking stoves. That's the best possible solution. But that would cost, for 1 billion people, that costs $300 billion to accomplish that. Okay. So we have been using open phone computational fluid dynamics. It's been very difficult. It's taken a whole year just to do an accurate simulation of a pot, much less a shroud. So we consider the work that we're doing now more like foundational in heat transfer. Like, for example, the pot that you saw with those complicated fins might be too expensive to really be practical in a low and middle income country, but the technology that we're developing for designing it might be extremely relevant to that, in including the analysis of shrouds later.
Okay, yeah, that makes sense.
I actually have a question about the EcoPot also. Is there a goal to focus on what you seem to be right now with like sort of things that would probably only be manufacturable by 3D printing, or maybe like a one-time use casting type of thing? Or are you also focusing on manufacturability?
So I have specifically asked the team not to consider manufacturing yet. I believe premature optimization is the root of all evil, right? The problem becomes too big if you try to build a radically more efficient pot and make it cheap at the same time. So what we're trying to do is to develop the technology, not necessarily the pot, but the technology that will let the pot be designed that's the best pot that we can possibly make. And then we'll worry about manufacturing.
Sure. I mean, that makes sense, but at the same time, design for manufacturing, if you come up with, well, I have a pot, it's incredibly efficient because it's got veins that go through the fluid and it's impossible to clean and impossible to make, it may be the most efficient pot, but what's the point if you can't build it? So I get the idea of not prematurely optimizing, but at the same time, it's got to be some path towards manufacturing, right? So I was just curious if that was a design constraint, or if, I guess you already answered that it's just what anything goes.
Well, so the thing is, we're only human and we can only do so much. So what you're saying is true, but if we tried to design for manufacture before we've even solved the problem of the heat transfer of the pot, I don't think we would make any progress at all. Now, there is one sense in which we have done that. We have insisted that the pot be relatively easy to clean. Okay. Now, a second, like for example, you have to be able to get the human hand inside it, and the inside of it has to be smooth enough that you could expect to clean it with normal scrubbing materials. In low and middle income countries, a lot of times sand is used as a scrubbing material as opposed to, something else. Okay. Now, one of the things that we do at Public Invention is we have, because everything is open, anyone can split off a project. So, for example, what you just described, putting tubes in there, might be an effective way to make a kettle as opposed to a pot. The definition of a kettle being something that heats only water. And so it really doesn't need to be cleaned. It is the same way that a stew pot or a rice pot or something else does. But once again, the production of a kettle is a different project. And we're just trying to succeed doing one thing. I mean, it's been my experience that just doing one thing is hard enough. So Lawrence is someone who could have been given several awards because he's both an inventor, an invention coach, and a technical writer, and he's had a lot to do with the NASA project as well. Thank you, Lawrence. I never let you have a chance to speak because other people were speaking. Before you leave, would you like to say something, Lawrence?
I've got a question for you, Rob.
Yeah.
I was thinking about what's the process like for proposing a new research project?
Megan, can you bring up our project list while I'm describing this, please?
Yes.
So we have a spreadsheet of 80 or maybe 85 ideas. About 60 of them are mine. 25 have been proposed by other people. Basically, you just have to do two things. You have to agree that it's open source because we're going to publish it, right? And you also have to write up like a one-pager. Okay. So one of the things about one of our core principles is that if you can go ahead and click through to the Excel file, I think the link should be right there. So one of our core principles is that ideas are cheap, right? So just coming up with an idea doesn't really mean anything, but it's also, it's a seed around which things can nucleate. So we have a lot of ideas here that have not been really fleshed out, and they're just like one-page description of an idea. And that's how some of these projects start. Many of these projects, however, have been actively worked on a team. Some of them have been worked on and then mothballed. Some of them have been worked on and then abandoned as obsolete. We have a lot of different statuses for some of these. The preliminary ones are the ones where we basically are just an idea. So anyone can submit an idea to us. And as long as you agree to make it open source, we'll add it to this spreadsheet. Once it becomes more than a one-pager, our process is we produce a GitHub repo. A lot of times we begin the documentation or the scientific paper that will be associated with it on that day. The repo is public. And then in the past, we've asked Mimi to start recruiting for it. Now, as you saw today, we have 8 or 10 or 11 active projects, but we don't have we don't have 85 active teams, right? So we have more ideas than we can possibly recruit for. And one of my processes is when a public inventor comes, I do two things. I tell them about the active teams, but I also ask them to look at that spreadsheet because I'm always hoping someone will just say, I love that idea more than anything. I'm willing to work on that idea, right? And then a new team will be formed in that way. In fact, there's one volunteer, Umit, is working on number spectra, which is a pure math idea. I've been trying to get someone to work on that for 4 years. And I finally found someone who thinks that doing the computer programming will teach him something and is interested enough in the math that he's willing to do it. Okay. Well, this has been a long meeting. I appreciate everybody who tried to be brief. You know, we had a lot to present here, right? I think there are a lot of college engineering departments that would be proud to present this set of projects here. And so for those of you listening, there's a lot of room on interesting projects and you get to work on an interesting team. So if you're interested in volunteering, contact me or through our Public Invention website, you can fill out a volunteer form and so forth. I see Lauria's here. Maybe she's in an airport. I'd like to thank Lauria for speaking again as a professional artist. Thank you very much.